So for letter A, what do you guys got? Gas, I agree. Here's the thing. We might disagree on a few, and that's okay. I'm just going to ask you for your justification again. And honestly, there's a few that are arguable, and you can say both ways, okay? All right, B, what did you guys say? Combination. What is the bottom layer? Solid or?
Liquid.
Okay, so my people who are saying liquid, why are you saying liquid?
Because they're not so tight together.
Because they're not tight together. Okay, so I would say it lacks structure. I kind of agree with my liquid people, but if you have an argument for solid, that's fine. All right, how about the top? I would say gas. I'm sorry, for the top layer on B. Gas? Okay. And then letter C. Now we're on C. Gas. All right. Cool. Letter D. What'd you guys say? I agree with the liquid again because they're all unorganized. Okay. All right. How about letter E? This one I'm going to say solid. There's a lot of structure for that one. Oh, sorry. There's a lot of letters on here now. All right. F. You could probably say either one. I'm going to put solid because they are in a straight line. And like whoever drew this made sure they were in a straight line for a reason. But you could argue liquid. Perfectly fine because there's a lot of space in between them, right? So that's fair. Whatever you want. Okay? All right. G.
Gas.
I agree. All right. H. Hold on. What? Those are diatomic molecules. Yep, so that's like your H2, N2. All right, letter I. Liquid, I agree. J. Okay, did I have anybody say liquid on that one? No. Oh, okay, all right. Some people do because they're like it's like a zoomed in version because they're not super far apart. So I don't know. You can argue either one. How about K? Same thing. So, yeah. All right, L.
Yeah, liquid.
I would say liquid because they're not far enough apart to say that's a gas, in my opinion. All right, how about M?
Solid.
N.
Gas.
O.
Liquid.
It's a combination. So what's the bottom layer?
Solid.
What's the top layer?
Gas.
Gas. That's exactly what's going on. This is going from a solid to a gas. Does anybody know what that's called? We're going to take a note. We're going to take notes over it today, but sublimation. Has anybody heard that word? Like sublime?
Sublime.
There's a band called Sublime, yeah. Okay. All right. How about P? Solid. Good. All right. And you could argue that one is liquid too if you want to say the spaces are really big. Okay. Okay. So do you guys, how are we feeling at this? Can you get a thumbs up or a thumbs down sideways about, like, could you interpret this for all of those categories? Yeah. Okay. All right. If you're struggling, make sure you come see me. Some people have the eye for it, and other people, it's really tough to, like, make your mind wrap around this zoomed in version, so it's okay. All right. In your packet, this is the, I believe, second to last page. The back of it.
Oh, yeah.
So if you just flip it, you should be at this one. We're going to take some really brief notes over this. I'm hoping that at this point in your life, states of matter are kind of a part of your life. So you guys should know what, a solid and a liquid and a gas are at this point. I'm hoping. Okay. But there are going to be a couple words that we're going to throw on here that will probably be new to you, so just make sure you're taking notes. We are going to spend a little bit of time talking about that graph because it definitely shows some stuff. So we're going to start up at the top. What is anything that has mass and takes up space? Don't overthink this. It's matter, yeah. Okay. And what is the measurement that you make using a balance? What do you use a balance to measure? Mass. Okay. All right, so for your states of matter, which one is the one that has definite volume and definite shape? Solid. Which one has definite volume but indefinite shape? Liquid. And which one has neither definite or volume or shape? Gas. And the other one is for plasma. No, yeah, it's another state of matter.
Are we gonna learn about it?
So we will not be tested over this, and we honestly, I don't do much with it, to be honest. Okay. Okay, so from these, I do have one extra thing that you guys need to add to this. I want you to put a little bracket on liquid and gas, because you do need to recognize, so I need you to be ready to categorize which ones have which, okay? And so if you remember from the last quiz that you took, there was a little Venn diagram that was your bonus question. That's what you need to be ready for on the test, okay? So that would be the thing to practice. So your liquid and gas, I want you to know that both of those are considered fluid, okay? So you usually relate that word to liquid pretty easily. You're like, fluids, yeah, right? But really what we're talking about here is the ability for your particles to kind of go within one another and stuff like that and just keep moving through and stuff like that, all right? So lots of movement in those particles and lots of the ability to move in the particles makes them fluid, okay? Gases are the only ones that are compressible. So compressible. So if you've ever seen like an oxygen tank, you compress a bunch of gas into that oxygen tank to make it last for a while. Okay, so it means you can take a bunch of stuff, like all the air in this room, compress it into a little area. Okay? And then there'd be nothing out there. Yeah. All right. So the whole idea, what it comes back to is how far apart those particles are. There's room to push them together. Does that kind of make sense?
Yeah.
Okay, so high pressure. All right, cool. Go ahead and draw yourself a little Venn diagram that you can practice on when you get home. And I'll have mine filled out too, and I'll post it up so you can kind of check yours. You want to put these into spots where things are similar or not similar. Solid is the only one that has a definite shape, right? But liquid and gas have indefinite shapes. The fluid goes between liquid and gas. Yes? It's not my process. Okay, so the other one that I want you to know is I want you to put KE right here in the middle of it all. Okay, what does KE stand for? Back in the day. Kinetic energy, right. Okay, so what I need you guys to understand is all particles are moving. Okay, they're all in motion. So they all have this kinetic energy. All right. Now we're going to go over your changes of state. So solid changing into a liquid. What is that called? Solid changing to a liquid. What does an ice cube do on a... Okay, there we go. Were you guys nervous?
Yes.
Okay.
It sounded too simple.
Yeah, no, that's why I saved this for the last day, was because it's just should be a review from life, to be honest. All right. The other word that I want you to put down for that, okay, is fusion. Because it's not a word you would expect, right? Because technically melting means you're getting looser, right? So things are kind of falling apart from each other. And in your brain, what does the word fusion tell you?
Together.
Coming together, all right? So it's kind of a weird word, so I do want you to put that next to it, because that is actually what it is. All right, a liquid changing to vapor. Evaporation, good. Okay, vapor changing into a liquid. Condensation. Nice work. So, let me see if my water bottle is still doing it. Nope, it already warmed up. But earlier it was ice cold. I took it right out of the refrigerator and it was all liquidy. What it was all the gas that's around us in our room. It was like got close to the bottle and it got so cold that it condensed down into a liquid. All right? So if you think about it, all the condensation on your bottle is like everybody breathing.
Gross.
Right? I know. Isn't that kind of gross? I think it's gross. I don't know. I think it's funny. Anyway, liquid changing to a solid. What is that called? Good. Freezing. And then the fancy word is, yeah, just like fusion. Solidification.
Oh.
That makes sense.
Yeah.
Oh, because it says solid. Oh. That's nice.
Solidifying. All right. Solid changing directly to a vapor. We just did this in the picture. What? Sublimation. There we go. So this is a new word for you. That is one to study. Yes, great job. All right, so your examples for that. Dry ice, which is solid carbon dioxide. Okay. I will have dry ice in the classroom next week because we need it.
Yay!
But so I'll bring it out and stuff, and we can look at it.
Why can't dry ice melt though?
Look it up.
Dry.
All right. So it actually. The other example that I will show you guys, I'm going to show all the classes tomorrow, is iodine because it's super pretty. That's my favorite one. Super toxic, but super pretty. Because, I know, right? So we're going to put it in the fume hood tomorrow, and you guys will get to see it. So that one sublimates very easily with heat as well, okay? And it's for the same exact reason that I was talking about the other one. We'll learn intermolecular forces here very soon, probably in the next 4 weeks. All right, number 6, vapor changing directly to a solid. Oh, nice work. Oh, he's so smart. It was all at the bottom. Does anybody know an example of what it is? Where can you find deposition? You can find it in your house.
Freezer.
It's in your freezers. That's the stuff that you scrape off and you're like, oh, snow. Right? It's the frost. Yeah. So if you put like a steak in the freezer, it's that gas that's what? Yeah, it's the stuff on the outside of that steak packaging that you can just kind of like scrape off. Now, this is not to be confused with, oh, I let the steak defrost a little bit so it was a little wet and then I put it in and it froze, all right? This is something that you put the dry thing in there, that gas is just getting cold instantly, which brings it down to the solid, okay? So, fun stuff. All right, so that one is the frost in your freezer. Cool. So now we're going to take a second to look at this nice little graph here. And what I want you to notice are just like all the information that's on there. If you look at the top, you kind of see your particulate diagram showing you what's happening as you turn into a gas, which I feel like you guys probably already knew this, right? Like solid, all your particles are together, then they get looser, 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 and then they turn into crazy things going berserk all over the place, right? Okay. So, what I want to also point out is who's on your axes. Whenever you get a graph, you guys, this is like a life skill for the rest of your life, forever and ever and ever. Please look at your axes. Like your axes are telling you the entire story, okay? So looking here, what do you guys see on the y-axis? What are we looking at on temperature? All right, so that's the thing that we can observe, right? We can put a thermometer into something. We can watch temperature go up, okay? Down at the bottom, what's across the x-axis? Right, so this is about absorbing energy and time passing, right? So as I am absorbing energy and time passing, think of it like you put a pot of water on the stove. I thought I mixed up the word. That was weird. All right, pot of water on the stove. So it sits there, right? And you're sitting there and you're like, come on, when is it going to start boiling? It's absorbing the energy. That's kind of what this graph is showing, right? So as it absorbs that energy, it's going to move through its states of matter. That's easy. Piece of cake. So what I want you to know is that diagonal lines, those are the ones that are your states of matter. Biggest mistake people make is they see those flat lines and they're like, there's the state of matter. Like I build up to it and bam, now I'm a solid. And I build up to it and now I'm a liquid, okay? That's not how it works, okay? You are a solid this entire time during the duration of this whole temperature change. You remain a solid. Then you have gained enough energy to kind of start becoming liquid, but you go back to solid and you kind of go back and forth. This is a point of equilibrium, okay? If you notice, what happens at equilibrium to the thing that we're observing? What happens to temperature? It stops, yeah, right? Okay, so temperature kind of just stays still. So temperature doesn't change for that time being until it gathers up enough energy to now go up another degree Celsius. All right? So in that instant, you'll watch the thermometer stop. Now, I will tell you the solid to liquid one, that's not an easy one to observe. The one that's easy to observe is going to be this one over here, your gas liquid. If you notice, we have a longer duration of time for that one, okay? But you will watch that thermometer stop at 100 degrees Celsius as it's going to turn into that gas, okay? So it's kind of neat, but we're going to come back to this in thermo. So you will see this graph now, and you will see it again later, and I expect you to remember all of this that we just talked about.
Easy.
Okay? So what's the most important thing? Look at what?
Axes.
Your axes, okay? So when we come back to this, just look at your axes again. You'll be like, aha, temperature stays the same. That's the big deal, okay? All right. If you look over here, here's just another reminder of your different states of matter and changing. So if the words don't work for you, that's another great thing. And we'll talk about enthalpy later in the year as well. So do you guys have any questions for me about phases of matter or states of matter? No? All right, so what I want you to do is turn your page over. You now are going to complete this while I finish getting stuff ready in the back. And then I'm going to have you come pick up your papers from the back. And then I will go over what your options are for your test. Because the other one's coming tomorrow. I'm sorry. So, no, like to do corrections on. I'm going to talk to everybody at the same time. So please don't come up to me with your test and start asking me questions when I let you guys go do it. We're going to do it by rows of two. Either a physical or a chemical property. You have the notes from 2 days ago. Okay, so if you look forward in your little packet. And then if it is a physical property, you need to tell me, is it intensive or extensive? Okay? Do you notice, do we answer that question for chemical properties? No. So for physical properties only, I want you to tell me intensive or extensive. So go back and look at your definitions. You need to know these. Okay? All right, so work on that with a partner, and then I'll let you know when to come back. They're exactly the same thing. So circle those and say equal. A boiling point, though, is not the same thing, so please don't ever tell me that. Okay? Okay. All right. Conducts electricity. No, it's physical. Intensive or extensive? I had to think. Sorry. Intensive. I know. That's because I was verifying in my head. All right. Ability to rest. Chemical. All right. Diamond has a hardness of 10. Physical. Is it intensive or extensive? Yeah. Intensive. Small diamond is just as good as big diamond. Kind of. All right. Reacts with water to form an acid. Chemical. Flammability. 25 milliliters of water. And extensive. Good. Okay. Area. Extensive. Good job. He keeps answering. All right. Extensive, right? So because if I make it a big triangle, is it the same area as a small triangle? No. All right. Viscosity. Physical. This is intensive. Doesn't matter how much you have. It's going to have the same flow rate. Okay? All right, density. Physical. Intensive or extensive? Oh, man. We've had now 2 tests and a quiz. Intensive. Density will not change. If I cut it in half, it's still the same density. Okay? All right, soft.
Physical.
Intensive or extensive?
Extensive.
Intensive.
Oh, man.
No matter what, right? So when you say extensive, like my people who keep saying extensive, you're saying that if you chop off half of, they're chopping sodium, I believe, in this one, right? Okay, but think about your pillow. Like your pillow has a certain softness to it. If you chop it in half, did you change anything about its softness? No, I mean, it's not as comfortable because it's just like small, but you don't change its softness, right? So that's what you need to be thinking about. If you chop something off of it, is it still the same? Yes. Then it's intensive. All right, gold color. Physical, is that intensive or extensive? Intensive. All right, reacts with gas to form water. Whatever. You know, the other way. It's chemical. I said that backwards. Shiny luster. Physical. Intensive. Does that have anything to do with its size?
Wait, is that about size?
Extensive has to do with size. Has to do with amount.
Unless if you cut it.
So extensive is based off of numbers and stuff. Okay. Ability to tarnish. Chemical. Yes. The yellow one is the one with the map, so you might have had a white version. Map and the equipment. Okay? Oh, you guys didn't go back there yet. Go. While you guys are doing that, I'm going to hand out the review. The test review. You guys didn't remind me.
Mace, you said you were going to
Stop talking. What? Yeah, you said I want to stop y'all after I'm done talking.
And then you stopped talking after when the bell rang.
You didn't remind me. No, I'm just kidding. All right. She didn't. Do you have plenty of papers on your desk yet? Should I just throw 4 more papers on your guys' desk?
No. Was I the only one that said no?
If you already took a review, then just don't take another one. I only have just enough. So if you have friends who are in my morning classes, they've been working on this. I apologize.
Well, one of my friends in your morning classes did.
Oh, I thought he was here. Oh,
You didn't do it?
Doesn't do anything.
Oh. In my morning class?
They haven't turned their summer project.
First? I know who from my second period hasn't.
I swear he
Because I keep calling him out, but I. Okay.
knows about it. That or he loves it.
What is the 6-week test business? What 6 weeks test? You will take a 6 weeks test, but I've never told you about a 6 weeks test. So I'm not sure where you got the idea that we do a 6 weeks test. This is a brand new thing that we talked about this morning. We never do, but we're gonna. So, but yes. So if you're asking about the replacingness, yeah, we'll see. I don't know if we're gonna do it this 6 weeks because we didn't prepare for it. So we'll see. Might not happen until next 6 weeks. All right, so let me go over what your options are. Okay, you have one test back. You'll get the other one tomorrow, so keep that in mind. You might want to knock out corrections for this one tonight, so you don't have to worry about it tomorrow. Okay, so if you have missed a multiple choice question, I'm sorry that it's a wrinkly paper. I've had this for 4 years now. I know, it's horrible. All right, so when you get something wrong, multiple choice wise, and it's the ones that are words or something like that. Okay, so a lot of this one. You just write in a complete sentence the correct answer was, and then tell me what the answer was. I would prefer you to put the word, but that's okay. If you want to put the letter, it's fine. And then you need to tell me why you got it wrong, basically. So This one I think is showing 3 sentences. I'm okay with 2 sentences, so I want to know, you're basically forming yourself a study sheet. How are you going to get it right the next time around, right? And that way, when I give it back to you, you now have a study sheet saying, oh, I'm not going to miss that question again, right? So that's the approach I want you to take on this, okay? So put enough details on there that's going to help you in the future. So biggest pet peeve. I got this wrong because I confused, or I didn't know what C was. And it was just like, there's no explanation. Go into your notes, get a fact, put it in there, okay? I want some effort on the corrections. This one, if you have an open-ended, I apologize for the big pink line. I can't get rid of it. I don't know how to. So if you have an open-ended question or any kind of calculation, you show me the steps. So you show the work, and then you write out steps. They do not have to be this elaborate, but they need to be good enough to where you can go back and say, oh, that's how you calculate average atomic mass. Or, oh, that's how you're supposed to do the sig fix. Okay? So try to use these to your benefit in the sense that you're going to have to study for it later anyway, right? Because you guys, at the very least, you guys are going to have a semester exam that's cumulative. So you're going to have to remember it at one point. Okay? So as far as what's going to happen, so this 6 weeks, I am allowing half credit back for corrections. So if you choose to take these back and you turn them back in, what that does is it prevents you from making 100, okay? Because obviously they're corrections. So half credit back is a really good deal. It actually is. I know it doesn't sound like much. It really is. So my people who got like the 30s and the 40s, it gets you up to a 75, 80, all right? It really does. So if you do the math, yeah. So do your stuff, okay? If you are wanting higher than that, because most likely you're probably not going to get above an 80 with corrections, okay? Then you do want to do a retake, but I need to either see corrections done in my hand, or you need to come sit with me in tutoring, and you should have done the review, okay? So that retake, that one the highest you'll get is a 99. Okay, I do prevent the 100, sorry. You get 100 if you got it the first time around. All right, so my people who got a 90 and above, in biology, I know you weren't allowed to do corrections. I'm allowing it this 6 weeks. So if you want to get a little bit higher, go for it, okay? Yes. Which question?